So where we left off yesterday was dividing decimals. So get to that place, okay? So as we kind of chug through this test, what I want you to know is that the entire test is not going to have, every single question is not going to be a different skill. Some of these questions are going to be repeat skills. So like number 7, I'm telling you, is going to be a problem where you divide decimals. There's a chance that there's going to be another question down the road that's also going to be a dividing decimals question. Okay, so I'm not going to give repeat examples for repeat problems. So, all right, do you have a pencil out, Emily? That does not look like a pencil. Okay, so number 8. What's number 8? Okay, so number 8 is finding the volume. Now, volume, do you not have one? Next year, you can't come to school without a pencil. Like, that should be the first thing you know. Thank you. All right. So volume is something we didn't get to. It was in the very last chapter of the book. Some of you have maybe played with this with IXL, and if you have, that's great. If you have not, you need to play with this a little bit in IXL as you prepare for this test by Monday. Okay? I know some of you aren't going to give any effort at all to prepare or to study for this test. I know that. I'm a realist. I'm not standing up here telling you everybody needs to do a little bit of practice. But I know that in the end, I'm probably going to only have 10 out of this room that really will. Okay? The others of you are just sitting in class today. You're going to write the stuff you need to write. And then you're going to be done with it. You're going to show up on Monday doing nothing to prepare. I know that. But for those of you who are going to put some effort into this, and I hope it's more than the 10 that I'm anticipating, what you need to do is go into IXL. Okay? Because IXL has places for you to practice volume. Now, what is volume? So in math, volume is not sound. It is space. So it's how much space an object takes up. Okay? So I'm going to give you an example of what I mean by this. So for example, if you look at this shape right here, that's a flat shape. That's called a two-dimensional shape. You can't fill up space in a two-dimensional shape. So how do you find volume? Well, you have to have a three-dimensional shape. So this means I'm going to turn this 2D shape into a 3D shape by drawing another rectangle that overlaps my first one, and I'm going to connect my corners. When I do, I now end up with a shape that appears to be something, and I know my drawing is not the greatest, but I have now produced a shape that is something that looks as if you could fill up space inside there, okay? And it might even kind of appear a little bit easier for you to see if you shade in the bottom. So now that thing looks like a Kleenex box, or it looks like a fish shape, okay? This is something that I can fill volume with. I can fill the space. So how do I figure out how much space is being occupied inside that object? Well, you have to use a formula. So the formula that you need is volume, which we represent that with the letter V, equals L, which stands for length, times W, which stands for width, times H, which stands for height. Okay? So to find the volume of an object, you will multiply the length times the width times the height. So in my example, I'm just going to make up numbers. I'm going to tell you that the length of this object is 5 centimeters. Okay? I'm going to tell you that the width, which is how wide this object is 2 centimeters. And then I'm going to tell you how tall, or the height, how tall this thing is 4 centimeters. So to find the volume, you simply plug the numbers into the formula. So if the length was what? 5, then it goes where the L is. If the width was 2, it goes where the W is. And if the height is 4, it goes where the height is. And then you just multiply. So in this example, if you multiplied that stuff correctly, what would the volume be? it would be 40. Okay. Now, that's volume. You probably saw stuff like that on that math test and we just didn't get to it. Now that you have a chance to see it, you're like, that's easy. Okay? But it sounded harder than really it is. So, is this necessary because I'm flying through? What? It is geometry. We just didn't get to it. Geometry is the last chapter in every grade's book. You may not get to geometry next year either. So just kind of, because it's hard to get through a book. All right. So let's move on. So that's question number 8. Question number 9 is, I can get to it. What in the world? Of course it froze. Question number 9, I'm just going to tell you because I'm going to have to log off and then log back on, is multiplying fractions. You all should know how to multiply fractions. I got to get back to it. So you don't really need an example for that one because you should already know how to multiply fractions. You can give yourself examples if you want to, and you can find those examples from IXL, from your workbook. You can make them up. I make things up all the time. So you can go to a parent and say, hey, can you make up a problem for me? And you can practice it that way. Okay. All right. So number 9 was hiding down here. I got rid of my shape. We didn't need it anymore. Number 10, dividing decimals. Make sure you know how to divide decimals, and those things should be pretty fresh in your brain right now. Just remember that when you divide decimals, what do you have to do first? Brady, move that decimal. Don't forget to move it. If you forget to move it, you're not going to end up with the right answer. Okay? Let's move on. Number 11, subtract decimals. Now, there's important things to remember with subtracting decimals. What are the things that we must remember in subtracting of decimals? So, item number 1 that we must remember is we must line up the decimals. So I'm putting a little star here so you don't forget, line them up. The other thing that you must remember when you subtract decimals is
add zeros if you're
yes, people, good work. Add zeros in those empty spaces. If needed. Yeah. Okay. Number 12. Geometry with triangles. So here's another question in a chapter that we didn't cover. Okay. So what do you need to know in geometry with triangles? So if I were to try to attempt to draw a 3-dimensional shape with a triangle, it is not as easy to do as it is with a square. But I'll give it my all. Okay. So we would have something that looks sort of like this. So hang on, I'm trying my best. This is going to turn out real bad, I can tell. It's bad. Okay.
That's not that bad.
You don't think it's that bad?
It looks like you're.
Well, that's kind of what it's supposed to sort of represent. What it doesn't show you that it's supposed to show you is that the base that it's sitting on, that bottom shape that it's sitting on, is supposed to be a square. That's not a square. Okay. So just kind of envision what you would envision a pyramid to be. Okay. So what you need to be able to do when you look at these things, these shapes here have something called faces. They have edges. And they have vertices.
I kind of figured out. So was it like this?
So,
Or like that?
kind of, yeah.
That's perfect.
So you need to know what a face is on a 3D triangle. You need to know what an edge is on a 3D triangle. And you need to know what a vertice is on a 3D triangle. Okay? This would have been something that if we had time, we could have gotten to, but we didn't. Okay? All right, number 13. Place value with decimals. So what do I mean by that? I gave you a little example there. So the example would be like 24.62. All you're going to have to do is tell me the name of the place that that digit is sitting. Okay? So if this was my example, where is that 2 sitting? What place? Just say it. Tens. That's the tens place. Where's the 4 sitting? The ones. Those are easy. Then when you get into the decimal land, you got to remember the names of those places too. What's the 6? That's the tenths. Too hard for me to write it. What's the 2?
Hundreds.
That's the hundredths. And if I had one more, it would be the thousands. It could keep going. We are not going to keep going, and your test won't keep going. But you need to know place value to the thousandths place. Okay. Number 14. Looks like I erased something I shouldn't have. Number 14 is subtract decimal with variable. So what does that mean? So the example of my problem is something like 18.6 minus n. Okay, n is called a variable. As you grow in math, you're going to enter into algebra land, and algebra is all about variables. And it's learning how to solve for a variable. Learning how to discover the value. What is that n? What number is that n supposed to be? That's what you're going to learn how to do when you get a little bit older. You're not ready for that just yet. So your baby stages of algebra is going to be seeing a problem like this, but then they're going to tell you in the problem, they're going to tell you in the problem what your variable is equal to. So they're going to tell you that n is equal to 4.2. So to solve for that, all you do is take the value of what they tell you n is, plug it into the problem, and solve. Okay? That's the baby stages of algebra. Eventually you're going to get to where they don't give you the value and you have to get it.
Like 18.6 minus n equals.
Yes, you got to have that equal sign in there, and that makes something called an equation. And you'll learn how to solve an equation. Some of you are going to learn you love algebra, and some are going to say you hate algebra. Typically, those that love algebra hate geometry. People that love geometry typically don't like algebra. Very rarely do you get somebody who really enjoys both. But as you get into high school, you have to take both. You've got to take algebra, and you've got to take geometry. Number 15, multiply numbers with base 10 and exponent. We've already done that. That is problem number 1. So I'm going to tell you, use number 1 for a guide. That's the exact same thing question number 1 had you do.
Oh, yeah,
Okay.
it is.
Huh?
It is. Can we just
Yeah.
get that one then?
Yeah, we're not doing that one. Yeah. All right. Let's move on.
We already have done.
Number 16, line plot graph. This is another thing that's part of that last chapter we didn't get to. I'm going to draw this out and show you what it means, okay? So this is where you're going to see a line. And on that line, you're going to have a series of numbers, like a 7, a 2, a 9, and a 4, okay? And above each of those numbers, you're going to have an X. And the X represents the information that you are looking for, okay? So let's say that my story is that the teacher had a class, and in the class there were, let's see, 7 plus 2 is 9, 9 plus 9 is 18, 18 plus 4 is 22. So the teacher had a class, there were 22 kids in the class. She wanted to see how many kids in the class had siblings that were those ages. So the teacher asked, how many kids in the class have a sibling that's 7 years old? One kid raised their hand. So they put an X above that 7. Then the teacher said, how many people in this class have a sibling that's 2? Nobody raised their hand. So we're not going to put any X's above 2. How many people in the class have a sibling that's 9? 4 people raise their hand. 1, 2, 3, 4. And then how many siblings in the class or how many people in the class had a sibling that's 4? 2. Okay, I just made that up. Okay, so there's your graph. It's giving you data. It's telling you stuff. So then there will be questions you have to answer, and the question might be something like, how many people in the class had siblings that were 7 years or older?
15.
How would you answer that? How many siblings in the class had kids that were 7 years of age or older? Xander? 5. Because this person right here, one of them had a sibling that was 7, and then 4 more had siblings that were 9. So to answer the question, how many had siblings that were 7 or older, the answer would be 5. Okay? If it said how many people had siblings that were 4, you would say 2. You just use the X's to help you to figure out the answers to the question. It's just a different way to make a graph, okay? Number 17, how to turn improper fractions to mixed numbers. You should know how to do that. We're not doing an example. You can make your own examples for that. Number 18, multiplying whole numbers. Okay, that's simple stuff. Come on, you're falling behind. Multiplying whole numbers, that's just like 82 times 26. There's no decimals, there's no fractions, just multiplying numbers. Number 19, multiplying fractions. Yep, you should know how to do that. 2 fractions that they give you, multiply them.
You've already done more today than you have yesterday.
No. Number 20, subtract fractions. Okay, now we haven't done subtracting fractions in a while, which is why I'm giving you an example. What do you have to remember with subtracting fractions? Please don't forget, Max. Yeah, you got to find the common denominator. That's what it's called, okay? This is what you guys got so good at doing, and then I pulled you away from this and we started multiplying and dividing fractions. So if this was your example, what would be the common denominator between a 4 and a 2, everybody? 4. A 4. So you would start building your new fraction that has a 4. Remember this? And then to find your numerators, you would have to divide here. Let's see, because I drew that in the wrong place. My brain is kind of getting fried, and the board is not cooperating. 4 divided by 2 is 2, and then 2 times 1 is 2. So that would come down here as your numerator. Do the same thing on this side. 4 divided by 4 is 1. 1 times 3 is 3. And then you bring down your sign and you subtract. So your answer becomes 1. Remember, with subtracting fractions, you do not change the denominator. Okay? All right. Let's move on to the next page. Ready? We got 10 left, people. We can do it. 21 is multiplying decimals. Multiplying decimals.
I always had a problem when I subtract fractions because even though it's dividing fractions.
This is where
the denominator. I'll turn the subtraction sign to
But this is where you show me retention. This is where you show me that you have retained. This is where you show me you have learned. You didn't just memorize it for the test, but you put it in your long-term memory and you'll know it forever. So that when you're my age, when somebody says you have your own kids and your kids come to you and say, hey, Mom, Dad, we're learning how to subtract fractions. Can you help me? You go, sure. I remember exactly how to do that. Okay, all right. There we go. So, number 22, types of triangles. What do I mean by that? Good. So, there are multiple types of triangles. There are 3 types of triangles that measure angles. Those triangles are called right, a right triangle, and it looks something like this, okay? It's got this angle in the corner that forms a perfect L. It's what your building is made out of. If you look in the corners of your building, every corner of our building is a perfect L. Our engineers build these things. You must build buildings with right angles. If not, your building's going to collapse, okay? So there's right angles. There's right triangles. There are acute triangles. Okay? They are these triangles that have these cute little smushy tiny angles. Skinny little angles. And then you have your last one is called an obtuse triangle. And an obtuse triangle has a really wide angle. Okay? So a right triangle measures what? Y'all know? 90. A acute triangle measures what? Less than 90. And an obtuse triangle measures more than 90. Okay? So those are your triangles that measure angles. There are triangles that measure sides though. Okay? So, all right, shout it out, Shane. You've got an equilateral triangle. Okay? Equilateral. My board is so not cooperating. Okay? It gets its name because every side is equal. Thus the name equilateral. Okay? So in this example, the sides would all measure the same thing. Like this, they would all be sub 3. Okay? But the other thing that they have to all match with are their angles. Piece of candy for anybody in here who knows how much angles are supposed to measure in every triangle. Right? What? Not 45. Yep. Nope. All angles must together average to be in every single triangle, James. 50? No, 180. All angles must measure 180 degrees. I don't have to give candy away today. Okay? So, let me another opportunity. So, let's look at this example here. This triangle has an angle that measures 90. I'm going to tell you that this angle up here measures 30. What would this angle measure? Carson, go get your piece of candy. Good. This would measure 60. Any figure that out? Because 90 plus 30 is 120. 180 minus 120 is 60. If they all have to measure 180. The other two types of triangles, so you have your equilateral, you have an isosceles. I know. And an isosceles triangle has two sides that are equal. You know how I remember this one? Because it's called an isosceles, and I have two eyes. Okay. So the isosceles triangle has two sides that are the same length, but one that's different. And then the last one is a scalene.
That's Spanish. That sounds like some sort of cleaning product.
Okay. All right.
Very clean. Smells like a
No. Use IXL for help. All right, come on. We gotta hustle. So use IXL for help with those types of triangles and what they mean. 23 types of quadrilaterals. Triangles have 3 sides. Quadrilaterals have 4. Okay? So these are things like squares, rectangles, rhombus, parallelograms. Okay? These things. Number 20. Come on, y'all, stop, please. Number 24 is another volume question. You've already been taught how to do that. Use number 8 as a guide if you forgot the formula. Okay. Number 25, multiply whole numbers. You all should know how to do that. Number 26, another multiply whole numbers.
Add fractions.
Number 27, adding fractions. What must you remember to do? Thank you, Max. Common. Don't forget to find the common denominator on that adding fractions problem.
Is it least common denominator or just common?
Well, least makes it easier, but if it's a common one, it'll work. Okay. 28, subtract fractions. Okay. Again, you gotta find a common denominator.
Why are there so many
So if you want to put yourself a little common denominator note there. Go for it. Number 29, multiply whole numbers. It's just like number 25 and 26. And then the last one is finding a decimal pattern. So I have to show you a quick example of that, and then we're done. So how do you find a decimal pattern? So in this example, they give you this, they give you that, they give you that, and they say, tell me what the next two would be. So here's what you have to do. I gotta be fast. We're running out of time. Okay? So listen. You gotta first look and see if it's increasing or decreasing. Is this increasing or decreasing? So this is gonna be an addition situation. We're gonna add something, but we gotta figure out what number we're gonna add. Shout it out if you know the number.
3.
No. So to figure out what the number is, you take the first two and you subtract them. Okay? So when I look at 4.4 and 3.1, if I take 4.1 and I subtract that by 3.1, 4.4, what am I left with? 1.3. Now I gotta make sure that that's the pattern. So I'm gonna look at one more example. I'm gonna go ahead and try and see if I subtract 7.5 and 4.4, do I get 3.1? You have to put the big number on top. You have to put the big number on top.
Yeah, but it's 1.3, not 3.
I know. So it's 3.1, sorry. Okay. So when I subtract this here, again, I get 3.1. So I know what my number is. My number is 3.1. So now to find the next two, what do? You take the last number they give you, and you add 3.1 to it. What do you get when you add 3.1 to that? Say it. 10.6. To find the next number, you take that number and add 3.1. That's the end of my show. It's been a long show. I've taught math for 175 days. I'm done. Okay.
Last class.